Welcome again to another session in this course. Here we are going to be looking at list operation in Python. We have been able to look at some of the properties of a list and how we can create a list. We also spoke about how important list is in our journey as a Python programmer. Now, there are several operations that we can do with list, and believe me, these operations are actually what makes list a dynamic data structure. So there are some of them listed here, and we are going to be looking at them one after the other. So we have append, extend, insert. We want to talk about slicing, the remove, pop, index, sort, count, reverse, clear, and copy. So we have spoken slightly about slicing in the previous video and also about the index. However, we will still look deeper into some of them. So let's start with append. I showed us append function in the previous session too. However, let me use this opportunity to explain it. It is used to add a single element to the end of a list. But that single element can actually be any form of data type. It can be a list, it can be a dictionary, it can be all sorts of things. And it modifies the original list in place and does not return a new list. So append does not return a new list. That was why I showed us in the previous session that the the memory location of the previous list was still the location after we have appended the list. So when we want to append, we use list dot append and then the element we want to add. And this is an example here. So we have my list and then we have my list dot append 4. So we want to append 4 to this list. So if I click on my list, you can see now that 4 has been added to this particular list. And if I say, so if I check the memory location of the previous list, and this is still the same thing because it's still the same list, we just append a new element to it. So let's look at it like this. We have names. These are the names. So we are going to print the names, and then I think let me make this simpler. So now let's check for the memory location of names. So you can see these are the names and these are the memory location before we append it. Good. Now we have another element which is a whole list in itself, and we want to append this list to names. So and then we are going to look at the memory location after appending it. So let's see. You can see now that it's now Olafemi Segun. Initially, now it is Olafemi Segun and the new list that we appended. And you can see that the memory location after appending is still the memory location before appending. So that is how appending goes. We are going to be using append a lot. We are going to be using it a lot. If you remember that code I wrote about getting a number divisible by 88 in the first session of lists, we will know that I used append there to extract each element and use append to actually make it a member of the empty list. So let's move forward. We are going to look at extend. Extend is used to add elements from an attribute such as another list to the end of a list. So there are structures in Python that are in form of a sequence, and these sequences can be iterated over. So when we have any form of this iterable structure, we can add elements from it to the end of a list. So it modifies the original list in place. It does not return a new list. So when we want to do that, we say list dot any form of iterable we want to use, whether it's tuple or string or any one of them. By the time we finish the data structure playlist, we would have understood this particular statement better. So let's look at it. So this is my list. It contains three elements, 1, 2, and 3. Then we have additional element from another list. You know that list 2 is iterable. So because of that, we can use extend with it. So we use my list dot extend additional element and then print my list. Look at what you are going to be getting. So you can see that this is different from append. Here now we say extend this. So every member of the previous element of the new element of the new list rather, or the new iterable has become a member of the original list. So you can see that we have my list 1, 2, 3. Then we have all these elements here in this also. Assuming we used append here, you know that append is going to give us something different, like here. Let's go up. So when we used append here, you can see that append actually carried the whole list and appended it here. So we can see that if we check for this one now, we have the whole of this list is just one element inside the new list. Rather, when we look at extend actually takes each individual element of the second list and make it an individual element of the new list. So this is the difference between extend and append. So let's use this particular method again and see what we have. So you can see now, Olafemi Segun, we have 100, 70, 60. So you can see now that this is the difference between append and extend. So whenever you want to use extend, you know what you are going to be getting. When you want to use append, you know what you are going to be getting, depending on the kind of task that you want to perform. Good. We have the insert method. It is used to insert an element to a list at a specific position. So it shifts the existing element to the right to make space for the new element. So the syntax is there. This is the syntax. List.insert the index that we want to put it and the element we want to add. So an example is going to be the best way to explain this. Let's look at my list. 1, 2, 3, 4, 5. Now we want to insert 10 at index 2. So this is 10 here, and then we want to put it at this index 2. So try and figure it. You can pause the video and try and figure where 10 will be. Will it be before 2, before 3, or before 4? I'll replay the video again. Let's see what you have. I will not tell us that one. So you can see that 10 is at the index 2. So this is 0, 1, 2. So where this index 2 is where 10 will be. It's as simple as that. And the 3 that was in that index before will be shifted to the right. So we have 1, 2, 10, and 3 has been shifted to the right. It has become index 3. Good. So this is where we are going to be ending this particular session, and we will continue in the next one.